Hello everyone, I'm going to go ahead and complete the second part to the Unit 3 review of quadratics as conic sections. There are only two problems left on the review guide, and both are to be completed without a calculator on the test. So I'm going to go ahead with the first problem, number 5, where you're given a graph and you're asked to write an equation for the parabola graph below. So before I do anything, I want to figure out which form of the equation I'm going to be using. And since this is a graph that opens vertically, I know that I'm dealing with a y equals x squared scenario. And so forgive me, I'm actually using my airliner at home, so it's a little bit, it may not be as neat as me writing on my smartboard, so bear with me. Okay, so if the equation is of the form y equals x squared, remember when we translate it, when we move everything around, it's going to be y minus k is equal to 1 over 4p times x minus h, the quantity squared. So there are a couple things I need to figure out. I need to figure out the value of p, and I need to figure out the values of h and k. Well, h and k, remember, are just my vertex. So if I think about this point and I consider the coordinates of that point, I know the x value is -2 and the y value is +3. So that gives me values for h and k. The next thing I need to figure out is the p value. And remember, p is your focal length. It's the distance from your vertex to your focus. And I can see that there's 1 unit between them. But I also have to remember that p can be positive or negative. And in this case, since my graph is opening down, I know that my p-value must be -1. So now all I'm going to do is substitute those values into the equation. Remember, all of your equations are going to have an x and a y, so you don't need to replace those values. So I've got y minus k, which in this case is 3, so I'm going to have y minus 3, is equal to 1 over 4 times p, which we figured out was -1, times x minus h. Well, since h is -2, when I do x minus a -2, that's the same as saying x plus 2, the quantity squared. And then the last thing I want to do is just write it so that I can simplify that fraction. So we'll have y minus 3 is equal to -1/4 times the quantity x plus 2 squared. And just remember, if this were a multiple choice question, for example, the answer may not be of this form. So one thing you can do is multiply both sides of the equation by -4, and that will give you the form of the equation that looks like this. -4 times y minus 3 is equal to x plus 2, the quantity squared. And so that would be another form of the equation that means the same thing. Both of these equations are equivalent. Okay, and remember, if the graph were going side to side, you'd be using the, it would be of the form x minus h is equal to 1 over 4p times y minus k, the quantity squared. So remember, h always goes with x and k always goes with y. All right. In the next problem, you're given a table of values. Now, in this problem, it actually corresponds closer to what we were doing in the last part of the unit before break, but we didn't really have time to cover it before then, so we saved it till the end. Basically, you're given a table of values, and you're asked to determine what type of function is represented in the table. Well, typically, what we would do is we'd enter the values into our calculator and construct a scatter plot. But remember, this is the non-calculator part of the test, so we have to figure out another way of determining what kind of function is presented. If you remember, when we were looking at series and sequences, what we often try to do is find a common difference or a common ratio. I think it's pretty obvious if we go from 11 to 41 to 89 all the way up to 155 and then up to 239, that we're not adding the same thing, and it doesn't look like we're multiplying by the same thing either. So I'm going to go ahead and do the common difference first. So for example, if I go from 11 to 41, I know that that's a difference of 30. Sorry, my handwriting is, it's not that easy to write with this thing. Okay, so that's a difference of 30. If I go from 41 to 89, and remember, if you need to jot this down and actually do the math, you can subtract along the side. So there's an 8. So I know the difference here is 48. And then from 89 to 155, So just do it by hand. Whoops. So 15 minus 9 is going to be 6. I'm going to make that a 14. And so that's going to be 66. And then from 155 to 239, it's going to be 4. And then I'm going to borrow 13 minus 5 is 8. Okay, so clearly since the first difference is not the same, since I didn't get the same value every time, I know this can't possibly be linear. So the next thing I do is I find the next difference to see if there's a common value there. From 30 to 48 is a difference of 18. From 48 to 66 is a difference of 18. And from 66 to 84 is also a difference of 18. So if you can remember, when the second difference is the same, then you know it must be quadratic. The other thing I noticed that really doesn't play into whether or not this function is linear or quadratic is the change in x. So notice that x is increasing by 3. You do need to make sure that x is increasing by a consistent value, but it doesn't necessarily have to be 1. Okay, so since we have a common difference that is the same, I know that the type of function is quadratic. And that's because the second difference is constant. And we're talking about the y values. So the second difference is constant. Okay. So you may be wondering, how on earth could we possibly come up with an equation for this function without using our calculator? Well, we can go back to what we were doing at the very beginning of the year with systems of equations. If you remember, if I know that this is a quadratic function, in standard form, every quadratic function can be rewritten as ax squared plus bx plus c. And that would equal 0. Or, I'm sorry, that would equal y. If we're writing a function, we want to make sure that we include the y and the x. Okay, so remember, every equation, every function is going to have x and y. What we need to do is figure out the values of a, b, and c. Well, if this pattern is perfect, and it looks like it is because I have the same difference and that's constant, I don't have to worry about doing regression. I can actually set up a system of equations. And what I'm trying to figure out are the values of a, b, and c that are going to make this work. So I'm going to start with my first equation. Basically, I know that if I plug 3 into this equation, the value of y that must come out is 11. So what I'm going to do is I'm actually going to replace the values of x with a 3. I'm going to leave the a, b, and c because that's what I'm trying to figure out. And we're going to set up a system of equations. So I don't know the values of a, b, and c, so I'm going to keep the a there. But I know that my x value is 3. So I'm going to plug the x in for, I'm plugging 3 in for both x's. Sorry, this isn't letting me write. Let's try this again. And I know when I plug 3 in, I must get an 11 out. And so I can do that with the next piece of information. So like, for instance, if I plug a 6 into this equation, I'm supposed to get a 41 out. So I'm going to write a second equation. Again, I'm still going to keep a, b, and c because I don't know those values. But I'm going to have an a times 6 squared plus b times 6 plus c is equal to 41. And because I have 3 unknowns, if you remember, we need to have the same number of equations for the number of variables that we have. So I need a third equation. So I'm going to use that third x value, 9. And I'm going to have a times 9 squared plus b times 9 plus c, and that's going to equal 89. And certainly you can choose other values, like I could use the 15 as my input or 12 as my input. But in this case, you do want to be a little bit careful because you're not allowed to use your calculator in this section. And so obviously this is going to take a lot of work to solve this system. My next step is going to be to rewrite each of these equations in standard form. And while I do that, I'm also going to want to just take a quick look at these values of C. Because if we're going to solve this system by hand, essentially what we're going to do is we're going to group two equations together and eliminate one of the variables, and then group the other two equations together and eliminate the same variable. Since each of these equations has a value of C that is the same, the C is going to be the easiest variable to eliminate. And essentially what I'm going to do is I'm going to multiply the second equation times -1, because when I do that, when I combine the second equation with the first and the third, my C values will end up canceling out. So I'm going to multiply, I'm going to kind of do two different things at once. I hope that doesn't confuse anybody. So now I'm going to rewrite each of my equations. So the first equation, when I rewrite it, I'm going to give myself a little bit more space. I'm going to start down here. So a times 3 squared, well 3 squared is just 9, but I'm going to write it as 9a because we're used to seeing it that way. And then I'm going to have my plus 3b. And then I'm going to have plus c is equal to y. Oops, I'm sorry, is going to be equal to 11. Sorry, I was mixing that up with the last piece. Okay, and then my second equation, I'll go ahead and do this in green. When I square 6, I get 36. So I'm going to have 36a, and then plus 6b. Oops, I forgot to multiply by -1. Let me do that again. So if I multiply, I'll save it. I'll just do this twice. Okay, so 36a plus 6b plus c equals 41. And then the third equation is going to be 9 squared, or 81a, plus 9b plus c is equal to 89. Okay, and so again, like I said before, I'm going to want to combine two equations at a time, and it actually doesn't matter which two equations I combine. I'm just going to do the first and the second, and then the second and the third, but the goal is to eliminate one of the variables. So if I multiply one of my equations through by -1, then my C variable will cancel, and I'm going to do that with the second equation since I'm using it twice, and I'm essentially just distributing a -1 all the way through. So all it's going to do is change all the signs of each of those numbers. If I were to multiply everything by -1, that's going to give me a -36a, that's going to give me a -6b, a -c, and a -41. So let's go ahead and combine the first and the second. Let me go ahead and just tell you which ones I'm combining. So when I combine the first and the second, -36a and 9a, when I put them together, are going to give me 27a. And it will be negative since 36 is negative. When I combine a 3b with a -6b, I get -3b. Notice that your c's cancel, and we've got 11 minus 41, which is going to be a -30. When I combine the second two equations, so my second and third equation, I'm just going to put this right underneath. When I combine 81 minus 36, let's do that up here, 81 minus 36, since we're not allowed to have a calculator, I'm going to have to borrow. 11 minus 6 is 5, 7 minus 3 is 4, so that gives me 45. So I'm going to have a 45a. I've got a positive 9b together with a -6b, that gives me a positive 3b, and then 89 minus 41, 89 minus 41, 48, and if you look, this is actually perfect because the next step would be to cancel one of my variables, a or b, and if you notice, b cancels perfectly, so that works out very nicely for me. I can go ahead and combine these two new equations. Let's do a different color, and my b's cancel, so I'm left with 45a minus 27, so 45 minus 27. It's going to give me 15. I'm going to have to borrow, so that's going to give me 18. So I'm going to have an 18a is equal to, well, -30 plus 48 is 18. Fabulous. So if I divide both sides by 18, I get that a is equal to 1. So that's great. But I'm not finished because I have to also solve for B and C. So now that I know that A is 1, I'm just going to go ahead and plug it into one of these two equations. I'm just going to plug it into the second one. So when I do that, I'm going to have 45 times 1 plus 3B is equal to 48. And so 45 times 1 obviously is 45. And if I subtract that from both sides, I get that 3B is equal to 3. And if I divide both sides by 3, I find that B is also equal to 1. So that's great. Now I have values for A and B. So now what I'm going to do is I'm going to plug those values into any one of the original equations that I had. So I'll plug it into the first one. So I know I have 9 times 1 when I plug in the A, plus 3 times B, which is also 1, plus C, which is what I'm trying to figure out, is equal to 11. Well, that's just 9 plus 3 plus C is equal to 11, or simply 12 plus C is equal to 11. And if I subtract 12 from both sides, I get that C is equal to -1. So now I have the coefficients for my standard form. Remember, the standard form of the equation is ax squared plus bx plus c is equal to y. So now when I rewrite my equation, I'm going to plug in what I know about a, b, and c. And so we said that a is 1, b is 1, and c is -1. So that means I'm just going to have 1x squared, or simply x squared, plus 1x, or simply x, minus 1 is equal to y. And that is how you can use systems of equations to come up with the equation to model a set of quadratic data. I will say that the problem on the test is pretty tricky, so be very careful with your calculations. You will get 1 point for being able to determine the type of equation. You will get 1 point for setting up the system. So just this part right here, whoops, change back to my pen. So this part right here will get you another point. So basically, just setting it up, understanding the type of equation that we're dealing with, and then setting up the system will get you 2 points. Now, this first point is part of the test. It's only part B that's extra credit, so you can earn up to 3 extra credit points. I think each of you can set up the system correctly to get at least one of those 3 extra points. And then you can earn the other 2 by solving for the other variables. I hope this was helpful, and good luck to all of you, because I'd like to see you all get those extra credit points.